Thank you all. All right, here we have Scotty. Scotty's our mascot. If you're not familiar with Ambiq, I'll go into a little bit of what Ambiq does. I appreciate you being here after lunch. Please don't fall asleep. I'll try to keep you excited. So, two important things about this title. First, there you go. Aha, all right. Two important things about this title. First, the practical edge AI. You'll walk around the floor today, you're going to see a lot of AI. We're going to talk about practical AI. What does it mean to actually deploy things in a battery-operated world? And then that kind of implies a second thing, where you have to make the microjoules count. All right. Whenever I go to a cocktail party, and I tell people that I'm in AI, they're like, oh yeah, Claude, or why is ChatGPT going to take my job, right? Which is fair. This is what the industry talks about when they talk about AI. But it didn't start that way. Like in 2016, 2017, AI was the stuff around the edge. It was time series analytics, it was computer vision, it was speech analysis, and so on. And it's crazy that that stuff is now the super important stuff for us. What you see on the periphery used to be in the cloud because the edge didn't have enough compute, or where it did have compute, it didn't have enough power. But now that we can do really sophisticated things on these edge devices, we're seeing a lot of much more complex, sophisticated analytics happening on your device, on your body, in cars, and so on. All right. So what's driving this? I think I don't have to lecture anybody here. If you're in the Embedded World Conference, you know about this. But there are a lot of benefits for moving AI to the edge. When you get rid of that round trip to the cloud, that round trip costs money, it costs time, it adds uncertainty, because sometimes that connection isn't there. So you ask your agent to do something and nothing happens. It just decreases the joy of a consumer using it, or increases the reliability of an industry using it. So moving it to the edge gets rid of all that. It also adds the possibility of privacy. Now, we know some people who, they collect all the data and analyze at the edge, and then they send the results back to the cloud anyway. But you don't have to do that. Before, you had to. And we also know how much a cloud API costs. So by moving that to your device, you're not incurring these cloud costs anymore. Okay. Well, one of the big barriers to moving stuff to the edge, this AI to the edge, was power. Now, if you're a cloud provider for AI, power is a TCO. It's a total cost of ownership. So reducing power is imperative, because power is one of the most expensive things you have. For edge AI, that's not the case. For edge AI, it's existential. If you don't solve the power problem, if you're in a battery-operated world, you will not have AI. Right? You cannot have AI if you don't solve the power problem. And that's where we come in. We're Ambiq. Ambiq stands for Ambient IQ. We've been around since 2010 or so. We've made 270 million chips out in the world, and I have to update this slide every time I give a talk, because that number keeps going up. And our mission is to provide ambient, intelligence, including AI, but not just AI, everywhere that you need a compute. The way that we do this, so Ambiq's claim to fame, the reason that we exist, is that we are low power. And everybody on the floor here is going to say that they are low power, and because that's what we strive for. But when I say Ambiq is low power, I don't mean 10% lower power or 20%. I mean 400%, 1,000%. 1/10 of the power of a typical MCU, that's where we come in. And we do that by lowering the voltage to where transistors are not supposed to work anymore. So that's what we call subthreshold, and everybody here in semiconductors is familiar with that. They're also familiar with, taking the class in the university. You're like, you don't do that. You keep your voltages really high. That means that the 0 and 1 is going to be very clear, and transistors work really well. Turns out if you lower the voltage, the energy lowers by a square of that. So there's a big advantage to lowering that voltage. And we've been working at this for over a decade. We've put together all these different techniques. It's not one thing. We call it SPOT, but SPOT is kind of a marketing umbrella term. There's a few hundred different things that we do to make this work, right? So you may see subthreshold designs in the lab with controlled voltages, controlled temperatures, but you will not see it on your wrist, and you won't see it in a car or anywhere in the real world. And that's what we've done. Of course, it's not enough. We have to also produce all the software and everything else to enable that, and we have that as well, and I'll get into a lot of that soon. Okay, we're going to talk in this presentation mostly about body-worn AI, industrial AI, but that's not all that SPOT is good for. It's a digital design technique. So even if you're designing, say something that sits in a server or in an autonomous vehicle where power is basically, yeah, autonomous vehicle is battery driven, but it's, you know, hundreds of watt hours, right? It's not what we're talking about. Even if you're doing that, the same digital techniques apply. So SPOT will extend naturally into everywhere where power is important. Even the data center, you know, it used to be that the most expensive thing about a data center was power, because once you exceeded power, you had to build another data center. That's the big, if you look at data center costs, they're a step function and they're driven by power. Now they're going for density, right? So they're trying to find ways to cram more things into that 12 kilowatt stack. And one of the ways to do it is hyper efficient compute. So we think SPOT applies all the way through there. Okay. Enough about Ambiq, enough bragging. Let's talk a little bit about our software solution. The stuff on the bottom is our MCU. On top of that, we have an SDK that makes everything easier to use, but also, very importantly, the low power easy to use. But I like to think of myself as a customer inside of my own company. Changing to low, like going to deep sleep is one function call from the Ambiq suite. Going from 250 megahertz to 96 megahertz is one call. I don't have to worry about what the CPU is doing. It just does everything automatically. And then on top of that, I've built, my team, I run the AI team. I've built a set of solutions that take advantage of all that low power goodness. And I'm not going to get into it here because I have a slide for that. All right. I lied. There's a little bit more bragging. We are introducing a new member of the Apollo. Apollo is our series of chips. So we're introducing Apollo 330 here. It's a Cortex M55 based device. It has helium. Helium, if you're into AI at all, is the vector engine is really good for running software-based AI. But it has a bunch of other stuff. It has a really good set of RAM and NVM, and it has great connectivity. Right, swing by the booth. We have infinite information, including this unreadable slide. I'm not going to go through it, except to say that helium AI is my favorite thing on the planet right now. And ARM, if you want to come over and give me a check for that, that'd be great. Let's talk about AI power. I did promise it was going to be microjoules count. Here what we're showing are the 4 standard MLPerf like benchmarks that AI uses, run across different MCUs. The one in the middle, the one that looks like a little teal, this guy here is our last generation, Apollo 4. That's the first one that I ran this benchmark on. And when I ran that benchmark, I thought I had done the math wrong. I thought I'd dropped a 0 somewhere because that was showing, compared to these guys over here, about 10x better power, right? When I realized it wasn't a math error, I went and hugged my wife, said I made the right choice, went to the right company. And then we go to the next generation, which is what we're introduced. Well, we introduced the Apollo 5 last year here at Embedded World, and now we're doing a 330. It is 6 or 7 times better than that last one, which is already incredible. So with great power comes great responsibility, and my job is to take advantage of those free MIPS, right? We have, inside the company, we kind of tell ourselves, you have free MIPS, how are you going to use them? And the way that I like to think about it is, imagine that you're plotting battery life versus AI capabilities, where AI capabilities is kind of a measure of the sophistication, how much compute you're going to spend on your AI. The more capable your AI is, the more sophisticated the model, the bigger the model, the quicker your battery is going to die, right? So that is what a system engineer that's putting AI on their device has to deal with. And you know, if your battery life is good, your customers are happy, right? So that's a safe region. If your AI doesn't use that much battery, okay, you're okay. Put it in. Alexa, hey Alexa, you know, that kind of. I'm sorry if that woke anything up. If your battery life dies, then that's too much, right? So that's what I call impractical AI. It's great for a demo. You're going to see it on the show, but when you try to put it on a wrist or something, it's going to kill you in an hour or two. And then there's like some iffy stuff, right? Here in the middle, maybe you can get it to work. If it's a really good feature, your customer is going to willing to give up a day of use, for example. And so I divide that into the practical zone, the demo zone, the floor zone, and then the iffy zone. All right, so enough of that. When you apply Spot, the curve changes completely, right? So this is not to scale, right? I'm only showing a little bit battery life, but remember, we're 10x times better. But now you have all this kind of room to grow space. So let me actually, let me do it to scale, right? Let me redraw that first one. It's down here. You put this guy in, now you have all the space. And all I'm showing here is 3x. In reality, it's 10x, right? So now you still have the demo zone and you still have the iffy zone, but they're tiny, right? There's a lot of things that you can do and not a lot of things that you can't do. And everything else is practical. So that's my job. It's like, okay, nobody's doing this big green zone of AI. Carlos, go take advantage of it somehow. That's been my job for the last 3 years, and we've had a lot of fun doing it. Right? Let's talk about how. Marketing slide. Zero information, but it's pretty, right? It's got transparent things and all that. But what it's showing is that we have a set of, a stack of AI tools. And let me talk about what those are. Okay, I'm not sure, does anyone here develop AI? Okay, well, all right. So you know the cycle, but everybody else, I'll kind of walk through it. It's not you don't just say, I'm going to do this AI. You start with a model, you experiment with it, then you try it out, it doesn't quite work, then you kind of circle back and you try a different model or you modify that model. And it's a cycle. And actually, and the quicker you can make that cycle, the quicker you're going to get to the final model. And so, because this team is basically all data scientists, we came up with a set of tools that accelerate that. We have an Ambiq AI kit, which is kind of an accelerator to a kind of model. So we have AI kits for different things. But we also have improvements to the training tools themselves. So a lot of AI stuff is designed for the cloud. When you try to put it on a small device, it doesn't work. So we have to modify a lot of the frameworks. We have an SDK that helps you just do all this very quickly and so on and so forth. My favorite tool here is a profiler. Once you kind of have a model in mind, you can very quickly get into trouble if you have a layer that is too big or takes too long. And so what the profiler does is profile that model on the actual hardware and give you feedback in a minute or two. And so that's part of that very quick cycle. It's my favorite because I wrote it. Okay. Let me dig into so if I go back one, it's the Ambiq AI kit, right? Let me dig into what an AI kit, this is what our data scientist customers use to kickstart their projects. It's everything, it's right. So it's what NVIDIA calls a model factory adapted to the embedded world. So you get training scripts. I'm going to give you an example of one of these in a minute, but you get training scripts, you get data set load and manipulation tools. data sets in this space are actually quite small, so we have to do a lot of augmentation. You get different model architectures. So our data scientists have experimented with every model, and there's model architecture, and there's advantages to some and disadvantages. We give you them all, and then you can pick which one is best for your application. We do some pre-trained models. You can use a demo, just kind of impress your CEO boss into investing more money, firmware, and so on. So it's everything you need. It's all in one place, and by the way, it's all open source. You can just go to GitHub and pull it down. So let me give you an example. Here's HeartKit. We're nominated for a kind of a show award, so if you guys haven't voted yet, find that click. And so what this does is gives you everything that you need to produce an ECG or PPG AI. Like you've seen these watches, they'll tell you, hey, you're having a heart attack, but actually very clearly say, we cannot tell you if you're having a heart attack, but you may be having afibrillation. So that kind of model is something that you build here. Now, that's not all you need. That's the top one. That's the thing that once you have that signal kind of figured out, you can say, okay, you're having a heart problem. You first have to collect that data, denoise it. When you're wearing something on your body, for example, there's so much noise. So that's a neural network that we've developed to denoise that signal. Then there's a neural network to segment that signal into the different parts of the heartbeat, right? And then once you have those different segments, you can start doing derivative things like AFib, bradycardia, and so on. Those are the tasks. Those are the things that those are basically the features that we're implementing. We talked about dev functions. So an AI developer has to do model preparation, has to do data set preparation, has to evaluate the model for accuracy and so on. So all those tools are there for you. And then there's public data sets. Now, all the models that we develop at Ambiq are based on public data sets. We don't have any proprietary. That does mean that when you use the model, you have to accept the same EULA that we did, and some of those have limitations. So we provide you a bunch of different data sets that you can start from. And then we have the neural architectures that I mentioned. These are all very standard, kind of known neural architectures that we have modified to fit on embedded devices. Like the TCN is very popular in time series things, but usually you see it running on a laptop or in a server. If you want to turn it into a streaming model, which is what you have, there's a lot of work. We did it for you. If you want to see a demo, by the way, come over. We have it running at the booth. Somebody kicked the sensor, so you may just have to look at the synthetic data. But it's all running, and it's all running on device. And with that, please come visit us. And if you have any questions, I'm happy to answer them. Thank you.